This will be a detailed analysis of this paper, where the eye controls its refractive state to its average of accommodation. The eye is a dynamic system. This will be an analog computer model of this system and the data being published here. The first sequence will be the no offset, where the system is driven by the accommodation signal, which of course then leads to an offset of 0. Starting at 5 diopters at birth, you then apply the accommodation signal at birth, and refraction comes down to about 0.7 of a diopter after 1 or 2 time constants. This will be the accommodation signal going down to -0.7 of a volt. So that's the control signal. Here's a system with, again, starting 5 diopters plus, and comes down at plus 1.5 diopters. The control signal remains at -0.7, but the point of this is that the output of the system is controlled by the -0.7 volt accommodation system. That makes the offset 2.2. Very basic concept, and this is proven in the spectral data. Here is the eye at +5 diopters with the offset applied, and it comes down to +1.5 diopters as expected of a control system. This is the applied control signal, starting high and going down to 1.5 volts. There is no perfect way to describe a complex system as sophisticated as the eye, but you must give all normal eyes credit for having that level of sophistication. The eye is not a billiard ball, and it was perhaps a mistake 100 years ago to sketch it that way. But in terms of direct science and respect for all eyes as control system, it turns out that, in fact, the eye is controlling its refractive state to its average of accommodation. Thanks for your interest.